Here's pre-calc. It's problem 10-27, and it says rewrite each of the following series using summation notation. And so it's got this one. And I noticed when I look at the answer that they started at k equals 0. You could have actually done it starting it with at k equals 1. But I'm going to just change my ways, and I'm going to show these with starting at k equals 0. So just know there's another way to do it besides this. So you'll notice that, yes, we have cosine, but you can just kind of look at the numbers, 1.2, 1.5, 1.8. They're going up by 0.3 each time. So they're going up like an even, steady rate. So we know that it's an arithmetic sequence. And so we can look for what it's going up by. It's going up by 0.3. And so I can write like a y equals mx plus b for it, like y equals 0.3x plus 1.2. So notice I'm letting b equal 1.2, which makes this have to be my 0th term. Like, in other words, to get the 1.2, I have to plug in a 0. So 0.3 times 0 plus 1.2 gets me that. And I'm just doing it this way because that's how your book, and I think your book insists on starting with the 0th term rather than the first term. So then we go, and I'm trying to find out what term this is, because when I make my summation notation, I want to start out with the 0th term. You could have started out with the first term and gone to the 10th term, and this number right here would be a 0.9, and that would be fine if you decide to do it that way. It's just that when you try to check your answer, you're going to see that the book doesn't do it that way. But anyway, you need to find this 9. There's no way for you to know the 9 unless you plug in. You can plug in the 3.9 for y to get this number. And then you minus, I hope that makes sense. You just solve it for x and find out that that was the 9th term. And so the cosine, it's just there, but this is really like an arithmetic sequence or series. So, and then on letter B, it's just got these numbers, and the thing that might be confusing about this is that the signs are changing. So I'm just going to look first at just the absolute value of the number. It looks like it's adding 2. I mean, I know the signs are alternating, but it's just adding 2 each time. So I wrote y equals 2n plus 1. I'm letting the 1 be the 0th term. So, and you can tell that you're doing it right because you plug in a 0 right here. 2 times 0 plus 1, that gives me that. I plug in a 1. 2 times 1 is 2 plus 1 is 3, but that doesn't give me the negative that I need. So, interestingly enough, in order to introduce the negative, you can introduce a -1 to the nth power, and that'll get you your alternating signs. Like if you multiply that by just the number part, see like the 0th term, I'm going to get -1 to the 0 is 1, and then 2 times 0 is 0 plus 1, it gives me my 1. And then if I do it with plug the 1 in, -1 to the first power is going to make my answer be negative. And then I plug in my 1 here, I get 2 times 1 is 2 plus 1 is 3. So that actually is going to come up quite often when you see alternation in the signs. You can try to remember that trick where you just multiply by -1 to the nth power. So I need to know what these two numbers are going to be, and I've decided to follow the book's lead and just start at the 0th term instead of the first term. You could have started at the first term if you wanted to, and then you'd go to the 101th term, and then this thing would have been whatever 1, you would have to go backwards to 1 minus 2. Okay, but I'm going to just follow the way the book does it. So, you didn't have this 100 yet, so you have to go here and figure out how to get this, how to find out what term this is. So you can go, where did I do it? Right here. I just took the 2n plus 1 because I realized it's just adding 2 each time if I ignore the signs. So I just went 2n plus 1 equals 201, and I subtracted 1 on both sides, and I got that x. This has to be the 100th term. And then when I multiply that by negative 1 to the 100th power, that's going to let it still stay positive. I hope that made sense.